2.7 combining functions. And first of all, there's these 4 basic operations, which are addition, subtraction, multiplication, and division. And those are pretty much as you expect they are. And then there's a 5th operation called composition. So there's these ones, and then there's composition. And we'll get to the composition later, but let's handle these right now. Okay, so let's do the first part, f plus g of 8. So that's the same as f of 8 plus g of 8 is what that is. And so if you come over here to the graph, let's see, 4, 6, here's 8 right here. And this is telling you that f of 8 is, what's this like here? 3. And this is telling you that g of 8 is 4. So that's going to be 3 plus 4, or 7 for the first one. For the second one, let's see, f of 8 minus g of 8. Okay, so you got the values already, and so that's 3 minus 4, or -1. And then the third one is f times g of 8. So that's going to be 4 times 3, or 12. And this is going to be 3, or this should be 3 times 4, but this is 3 over 4. Okay, because that's f of 8 over g of 8. And we determined that that's 3 and that's 4. So 3 over 4. Okay. So that's the first exercise. Shouldn't be too bad. Number 2. Right. The thing about this homework is like a lot of times they just kind of teaches you the concepts. By definition, f circle g of x. Okay, this is the other one that I'm talking about. This is composition. Composition of 2 functions. And this notation is it can be a little bit confusing, but what it is whenever I see this, I rewrite it like that. Whenever I see that, I rewrite it like that. And that's what the answer is for that part. Okay, so if g is 9 is 12 and f of 12 is 21, then f of g, okay, so again, you do it this way, f of g of 9. And so you start with the innermost one and you evaluate that first. So g of 9, okay, so it says g of 9 is 12. So that's going to be f of 12 right there. Okay. And then it says that f of 12 is 21, so that's 21. So that's going to be the answer, 21. Okay, next exercise. If the rule of a function f is add 9, so f is add 9, g is multiply by 9, then the rule of f of g, so this is, again, that's f of g of x, whatever. So you're going to do, even though it goes from left to right, you're going to do g first. You're going to do the g first, okay? So the g first, because here's your x right here, and it's getting acted on by g before it gets acted on by f. So that's going to be multiply by 6, then add 9. And 9. And then likewise over here, this one, you're going to be f first, because f is acting on the x first. And so it's going to be add 9, then multiply by 6. Okay, let's move on to the next exercise, which is how can we express these functions algebraically? Okay, so number 4, suppose the rule f is add 1. F is add 1. So that would be x plus 1. So you start with x and you add 1. Okay. G is multiply by 9. Okay, so multiply by 9. That would be 9x. So you start with x and you do whatever the instructions say to do. Okay, f of g of x. There's a couple ways you can think of this. So you're going to do g first, and then you're going to do f. So it's multiply by 9, then add 1. So you could think of it this way. Another way you could do it is just write it this way, and then replace the g of x with what it is, a 9x. Okay, so that g of x got replaced with a 9x. And then plug this into here. Everywhere that you see an x here. So, because like if you look at this expression, the x has been replaced with a 9x, so replace the other x with a 9x. Okay, and so you get that. Okay, this one is g of f of x. So here you're going to do f first. You're going to do f first. So add 1, then multiply by 9. So add 1, then multiply by 9. So that when you do that, it's going to be like that. Okay, so notice that there's a difference. It matters what the order that you do things. Okay, another way that you can look at it is like this. So first you're going to add 1. So first you're going to do the f, which is x plus 1. And then you're going to, this x right here got replaced with an x plus 1. So this x also gets replaced with x plus 1. Like that. Okay, any questions at this point? Okay, let's move on to the next exercise, number 5. Let f and g be functions. The function f plus g of x is defined for all values x that are in the domains of both f and g. Okay, so essentially this right here is f of x plus g of x. So if you can't put an x into here and gets a value in, if there's a value of x you can't put into here, then you can't put it into the whole thing. Even though you could put it into here maybe. Okay, and vice versa. If you can put it into there, but you can't, if you can't put it into here, but you can put it into here, then you still just can't put it in to this one. So it doesn't work. The same thing with this right here, both f and g. Now, when you're doing f divided by g, then you have to have both and f and g again. But then additionally, you can't have g being 0 because this right here is f of x over g of x. And if g of x is 0, so if you plug an x into here, let's say x is 5. Let's say g of 5 is 0. You plug a 5 into there, then this whole thing is going to be 0. You're going to be dividing by zeros. You can't do that. So g of x cannot be 0. So whatever value x you put in there, you can't give it a 0 for g back. Okay, number 6. Let f and g be functions. The composition, again, that's whenever I see that, I like to rewrite it like that, is defined for value of x for which the domain of f of x, x is in the domain of g, and g of x is in the domain of f. Okay, so it's interesting because you can actually have this composition is another function, okay? So f and g are 2 functions, and the composition is a third function, okay? Another function that's not f or g. But you can actually, it could be this case where there could be a value of x that is not in the domain of f, but when you plug it into here, apply g to it, you get a value that's in the domain of f. And then, so then you can plug it into the composition in this way when it's f of g of x. Okay, but if something's not in the domain of g, then you can't plug it in right into there. So it has to be in the domain of g, and then g of x is in the domain of, so x has to be in the domain of g. G of x has to be in the domain of f. Okay, number 7. So here's a bunch of values, a bunch of exercises that we're going to do. So we have f of x is x, and g of x is the square root of x. Okay, so let's just find f plus g. So that's just going to be x plus the square root of x. And the domain is going to be all values that you can plug into here, and also you can plug into there. So that's going to be, so you have to have a whatever when you take the square roots, you have to be a number that's greater than or equal to 0. Okay, and so that translates to 0 to infinity, including the 0, but of course not including infinity. Okay, and then f minus g, so that would be this minus that. Same thing as the second part. F times g, that's going to be x times the square root of x, and the same thing with the domain. And then f divided by g, so that will be x over the square root of x, which is the square root of x, except you can't have x being 0, so this one is actually 0 to infinity, and not including the 0. Okay, so even though we're saying right here that f over g of x is equal to the square root of x, and you can plug a 0 into here and get away with it if no one's looking. But in reality, because this is this divided by that, you can't plug a 0 into here. Okay, so this actually is not quite equal to this, because this can be 0, we can have a 0 for x over here, but you can't over here. Okay, so but anyways, this is the domain. So this domain is different than these others, where you're including 0 in these ones. This is not including 0. Okay. Number 8, we have more functions. So this and this, f plus g. So these have a common denominator. So when you add them together, then you just can add it like this. So you get x plus 8 all over x plus 9. And then the domain, the only problem is you can't have a negative 9 in the domain. So okay, so in other words, you can't have this is your denominator. It can't be 0, right? That means x can't be negative 9. Okay, f minus g, so that would give us 8 minus x over x plus 9. And again, the domains can be the same thing. Whoa. Well, I said infinity, but I wrote 0. Okay, so f times g. Okay, this is going to be, when you multiply these together, you multiply the numerators. And then you multiply the denominators. And so that's going to give you x plus 9 squared in the denominator. And then the domain is going to be the same thing. Okay, f over g. That's this divided by that. Okay, so when you divide, you can take the reciprocal and multiply, right? Like that. And then those will cancel. And you get 8 over x. Okay, the domain is a little tricky. You can have 0 in the domain because that will make this denominator 0. You also cannot have a negative 9 because that messes up f and g. So you have to exclude those 2 points, but everything else is fine. So that's how we exclude the -9, and then this is how we exclude the 0. Okay, any questions about this or any previous exercises? Okay. So number 9, find the domain of this function. Okay, this is a difference of 2 functions, right? So you want to take this first one, and that x plus 3 has to be greater than or equal to 0. But then you also have this second one right here, where there's a couple things. First of all, 6 minus x has to be greater than or equal to 0. And then the other thing is that because this is in the denominator, x can't be 0. Okay, so you have all these restrictions. And so we calculate each of these. X has to be greater than or equal to -3, right there. Over here, let's see, if we take the x to the other side, well, let's take the 6 to the other side. And then multiply by -1. And you have that. X less than or equal to 6. Okay, so less than or equal to 6, that would be like there. Greater than or equal to -3, that would be right there. So everything this way and everything that way. Everything this way and that way, excuse me. And then 0 is excluded, okay? So the answer is going to be from -3 to 0. I'm going to exclude that with open parentheses, union 0 to 6. Okay, so including -3, because this can't be 0. Including 6, because this can be 0, and then but not including 0 because this is 0 in the denominator. Okay, number 9. Okay, so before we said that if you're taking f plus g, then the domain is only the domain of, to be in the domain of f plus g, you have to be in the domain of g, and you have to be in the domain of f. So that means that the domain is going to go from here to here, because even though g extends further, f doesn't. So you can't add. And then even though f extends further over here, but g doesn't, so the domain has to end right there. So it's going to go from -2 to 3, if those are what it looks like, okay? Okay, but that really doesn't matter. So let's go ahead and look and see what it is. So now the way that you should look at this is you should look at this value and that value. So you should look at each of these points here and determine, like if you were, this looks like a -0.7, this looks like +1, right? And so that's going to add up to something over here. So you're going to get some value right there. For this point here, this looks like -1, that looks like +2. Okay, so 2 minus 1 is about 1. So you're going to get, so your value should be about right there. And you can look at like all the other points as well on the graph. You can look at more points. So like this one and that one, this is about 1 and this is up here, but this is +1. So then the value is going to be over here. Okay, and that's 0, that's there. So that's just going to, so the value is going to be there. Okay. So you kind of get an idea of what the graph's going to look like. You know, something like I don't know, something like this. And this graph, no, it has to be right here, so that can't be it. That can't be it either. This one could be it. That one, that can't be it. This one could be. This is the only one that could be. Based on just that first point that we were looking at, this is the only one it can be. Okay. Number 11. Use f of x equals 5x minus 2 and g of x equals 3 minus x squared to evaluate those. So let's start with the first one. F of 2. What you can do is just plug a 2 into here. And that's all inside. Okay, so that's all inside right there. And then just evaluate that. That's 10 minus 2, which is 8. And then, so you're looking at f of 8, so 5 times 8 minus 2. Then plug the 8 into here. So that's 40 minus 2, or 38. And g of 3. Plug a 3 into here. That's 3 minus 9. So g of -6, plug a -6 into there. That's -33. Okay, and then number 12. Okay, f of g of x, which I always like to write it like that, f of g of x like that, instead of writing with the circle there. The reason is that now I can, you start with the innermost one, and g of x is equal to 3 minus x squared. So I can just replace that, this whole g of x with a 3 minus x squared. Okay, so I have f of 3 minus x squared. F of x is 5x minus 2. So this x got replaced with this. So I have to replace this x with that also. In parentheses, like that. So this is what we have. And if you simplify that, let's see, distribute the 5. That's 15 minus 5x squared minus 2. So that's 13 minus 5x squared. And then g of f of x. So I replace this f of x with 5x minus 2. And then I replace this x with the 5x minus 2. Okay, so we have this right here. When you square something, it's the same. There is a formula for squaring stuff, and probably some of you know it. But if not, that's fine, because you can just write it like that and see what it is. Okay, so there's this minus there. Okay, so this times this, the first one, that's 25x squared, plus the first and the outside ones, the first and last, that's minus 2. 5x times 2, that's 10x. And then the inside one's another minus 10x, and then the last one is plus 4. Okay, so 2 times 2 is 4. Okay, now I'm going to distribute that in, so that's minus 25x squared, and that's plus 10x, plus another 10x, and then minus 4. Okay, so 3 minus 4, that's -1. I'll start with this one though, negative 25x squared, plus 20x. Those two add to 20, and then there's 3 minus 4, that's -1. Okay, any questions at this point? Okay, we'll move along to number 13. Use the given graphs of f and g to evaluate the expression. So f of g of 4. Okay, so what you do is you start with the 4 right here. Here's 4 right here. And you're looking for g of 4. Which is going to be 3. So 1, 2, 3. This is level is 3. Okay, so this is telling you that g of 4 is 3. Okay, so that means that f of g of 4 is equal to f of 3. Okay, so this gets replaced with a 3. Now, here's 3 right here, and f is right on the x-axis. This is telling you that f of 3 is 0. So that's going to be 0. Okay, number 14. Use the table to evaluate the expression. So this is f of g of 6. Okay, so let's take a look at g of 6. So what you do for that one is you come over here to 6. Here's g. G of 6 is 4. Okay, so that gets replaced with a 4. Okay, because g of 6 is 4. So that goes in here. And then f of 4. So here's 4, and here's f. So f of 4 is 3. Okay, so that's going to be 3. Okay, great. Number 15. Consider these two functions and find the following. So first of all, f of g of x. So that's f of g of x. So replace the g of x with whatever g of x is, which is x, the square root of x minus 7. And then, so g of x is x minus, the square root of x minus 7, so I put that in there. Then here, the x got replaced with the square root of x minus 7. So I replace this x with the square root of x minus 7 in parentheses. And the square root and the square kind of just cancel each other out. So we get that one. The domain, so this domain of this is everything. If you just look at this expression by itself, right? The domain is everything, all real numbers. However, this is a composition of g and f, and g, the inner function here, g, you have to be able to plug into here first. So you need x minus 7 to be greater than or equal to 0. So x greater than or equal to 7, which is 7 to infinity is the domain. Okay, now this one, g of f of x. So that's g of f of x. So you're going the other way, which is typically not going to be the same as the direction typically matters. So this f of x is x squared, so replace that with an x squared. And then you're going to put this x squared into here, like that. And then find the domain. Okay, so for this one, the inner function is x squared. So you can put anything, you can take any value and square it. So that's no problem. The domain of f is everything, so that's no problem. But at this point, you have to, whatever you get, you have to be able to plug into there. Okay. So to find this domain, you're going to take what's inside the square root and make that greater than or equal to 0. So x squared has to be greater than or equal to 7. Now, you could just take the square root. If you take the square root, then you get x greater than or equal to the square root of 7. But that's not the whole picture, because if x is less than or equal to negative square root of 7, then that's also going to work. So all values, so if you have something that's greater, let's say you have like 4, for example, okay, which is greater than the square root of 7, and you square that. If you plug a 4 into here, you're going to get 16. 16 minus 7 is 9, so that works. But if x is negative 4, that's also going to work, because you can plug a negative 4 in here, and you're going to get positive 16 when you square it, and then you subtract 6, you're still going to get a positive number. Okay, so numbers like that are also going to work. So things here and here is going to work, and so the domain is going to be negative infinity to negative the square root of 7, including that one, union from the square root of 7 to infinity. Okay, so that's going to be the domain right there. Okay, now f of x. That's f of x. This is x squared. And then this x got replaced with x squared, so this x gets replaced with an x squared also. But when you have this power quantity raised to a power, that's equal to the product of 2. 2 and 2 is 4. So you get x to the 4th. And then there's nothing wrong with anything. You can plug anything in here, and then anything here works. Everything works. So the domain is going to be negative infinity to infinity. Okay, number G. So replace the g of x with a square root of x minus 7. And then, so you've got g of the square root of x minus 7. Contrast that with g of x. So when you're looking at this x has been replaced with that. So you replace this x with that. Okay, and that's going to be the answer for that part. Okay, now it's going to be tricky, because you need to have numbers that you can plug into here first. So x minus 7 has to be greater than or equal to 0. So x has to be greater than or equal to 7. That has to be true. But you also need to be able to plug numbers into here. And in particular, this big square root right here, you need whatever values of x you plug into here, you need for this expression to be greater than or equal to 0. You need for that expression to be greater than or equal to 0. You can pull this 7 over to the side, like that. You can actually square both sides in this case. Generally, you have to be very careful about squaring both sides of an inequality, because that could flip it, okay? Or it could have, or you don't know, or you could be in a situation where you don't know where it does. Okay, so I'm just warning. Okay, so just a warning. I'll say it after. But add 7 to both sides, and you get 56. You need to satisfy that and that. Okay, but this one, and if you're greater than or equal to 56, then you're greater than or equal to 7. So this one's going to work. This is needed. Okay, so, but let me just caution you that you can't just square both sides usually. If you know that both sides are positive, then you can square both sides and you're fine. If you know that they're both positive, this one has to be positive because the x minus 7 has to be positive, because otherwise you can't take the square root. And when you take the square root, this means positive square root, so it's going to give you a positive number. Because, like, for example, if you, like, for example, let's say we have 4 and -2. Okay, so this is true. 4 is greater than or equal to -2. If it was just greater than, that would also be true. Wait, no, this is not the one I'm after. Hold on a second. -12 is what I meant to write. Okay, 4 is greater than equal to -12, right? So this is true. But if you square both sides, this is 16, this is 144, then it flips, okay, direction. It's not the same. So you have to be careful, because you need to have these have to be both positive here before you square them. They both have to be positive.